Today I will be going some topics for the 1324 course. There's about, as instructors, we try to pick, some topics, and I believe all these topics, will probably be on your exam. Maybe not all of them, but most of them will be on your exam. Okay, this is exam one review. Okay, now first, let's start by graphing linear equations. Graphing by plotting points. So we're going to plot points. It's always wise to use a table. You know what, guys? Let me go back. Let me turn off. Let me go back and turn off the. Here we go. Let me start again. I went back and muted the other one. Let me see here. Here we go again. Let's start again from the beginning. Okay, here's okay. We're going to be graphing by plotting points. So when we plot points, we're going to pick values for x. It only requires to graph a line only 2 points, but here I'm going to use 1, 2, 3, 4 values for x. If I start with -1, okay, I'm going to plug it in. I'm going to plug in -1, 0, 1, and 2. Okay, so I'm going to go back to my equation, and I'm going to plug in -1 where the x is. Then I'm just going to simplify. So it's going to give us 2 plus 3. So when x is -1, y is equal to 5. Now I'm going to plug in 0 for the x. So when x is 0, we're going to multiply -2 times 0. It's going to give us 0 plus 3. So when x is 0, y is equal to 3. We keep repeating the process for also 1 when x equals to 1 and x equals to 2. So when x equals 1, we're going to plug in the value 1 for the x. Simplify, it's going to give us 1. So when x is 1, y is 1. And the point is 1, 1. And finally, when x is 2, we're going to plug it in for the x. It's going to give us -4 plus 3. So y will equal to -1. So when x is 2, y is -1, and the point is 2, -1. Now, we're going to graph it by plotting the points. So -1, 5 will be up here. Then it's going to be 0, 3. Then it's going to be 1, 1. And then 2, -1. And now those points should connect on the line. If not, it means we did something wrong, right? But in this case, everything connects. So all we do is connect all the points, and there's a line. And like I said at the beginning, to graph a line, we only need 2 points, right? But like I said, I use four values because at times on the web assign, on the My Math Lab homework, they want you to use more than 2 points. Okay, now we're going to graph the very same graph, but we're going to do it different. Instead, we're going to use y equals to mx plus b. Okay, the solution, we need to find the slope, which is the m, and the b, which is the y-intercept. The slope is -2, so it's going to be -2, which means it's going to be 2 down and 1 to the right. From where? From my b, which is the y-intercept. My b is equal to 3, so my y-intercept will be 0, 3, and that's my starting point. So we start at 0, 3. It'll be up here, 0, 3. Then we're going to go down 2, 1, 2, and 1 to the right. So those are 2 points, and we connect them, and there's a line. You see, guys, this is the same one as number 1, but number 1 we did it by plotting points, and number 2 we graphed it by using the slope-intercept form. Let's do another one, okay? So the slope is equal to 3. So it's going to be 3 up and 1 to the right. My b is -5, which is a y-intercept, is 0, -5, which means I'm going to start at 0, -5. So we're going to come down here at 0, -5. Then we're going to go up 3, 1, 2, 3, and 1 to the right. So it's going to be 1, -2 the point. Then all we do is connect the lines, the dots. the points, and there's our line. Number 4, it says graph y equals 4. If we notice the slope, there's no, I mean, the slope is 0 because there's no x, right? So the slope is 0. So we know it's going to be a horizontal line, and the b, which is a y-intercept, will be 0, 4. So this line is going to be a horizontal line starting at 0, 4 up here, right? So, right, and then we pick another point anywhere on the horizontal line. So that's my line. Observation. When the equation is y equals to a number, right, it's going to be a horizontal line at that number. Number 5, x equals to -2. So find the slope and the y-intercept. When x equals -2, the slope is undefined. So it's going to be a vertical line. When there's no y on the equation, just x equals to a number, it's going to be a vertical line. So we're going to go at x equals -2, and we're going to just draw a vertical line on x equals -2. So that's my line. If you guys have any questions, just put it in the chat, and one of the moderators will let me know, because when I share my screen, I cannot see. I cannot see if somebody has, if somebody raised their hand or they put something in the chat. I cannot see that because I'm sharing my screen. But the moderators, will help me. Will let me know, so that way I can answer some of the questions. Okay, now the observation, when the equation is x equals to a number, right, it's going to be a vertical line at that number. Number 6, graph -5x minus 2y equals to -10. Solution, we need to put it in y equals to mx plus b form, which is called the slope-intercept form. So we have to solve for y. So the first step here, we're going to add 5x to both sides. Okay, now we're going to divide every term by -2. So if we do that, we're going to get y equals to -5 x plus 5. So now we got our slope, which is -5/2, which means it's going to go 5 down and 2 to the right from the b, which is a y-intercept. So 0, 5 is my starting point. Right, so we're going to start at 0, 5, so it's going to be up here, 0, 5. Then we're going to go down 5. Let's see, 1, 2, 3, 4, 5, and 2 to the right, 1, 2. We connect the 2 points, and that's our line. Now, number 7, we're going to graph the very same one as the previous slide, but this time we're going to do it by finding the x and y intercept. Okay. So here are the rules. To find the x-intercept, we let y equals 0 and solve for y. So, right, so we're going to let y equals 0, so we're going to plug in 0 for y. So it's going to give us -5x equals to -10. We divide both sides by -5. So we get x equals 2. So the x-intercept will be 2, 0. Right, so we plug it in there. So we plot it 2, 0. Now to find the y-intercept, we let x equals 0 and solve for y. Right, so we're going to let x equals 0 and we solve for y. So we get -2y equals to -10. We divide both sides by -2. So it's going to give us y equals 5. So the y-intercept will be 0, 5. Now we connect that point. We'll plot that point. Now we connect the 2 points and we got our line. Okay. So like I tell my students, if the equation is in the form ax plus by equals c, then I like to use the x and y intercept. But if the form is in y equals to mx plus b, then I'll graph it the way we did it in the previous slides. Now, I also tell my students that, the graphing with the x and y intercept, it can be done in your heads. Okay, so let me show you what I'm talking about. I call this the cover. Okay, because you're going to cover the x when x is 0, and you're going to cover the y when y is 0. Let me explain what I mean about that. For example, find the x-intercepts. Okay, we're going to let y equal 0. Right, so if you let it y equal 0, right, you can cover the negative 4y, right, because it's, if it's 0, then it'll just be 0. So then in your heads, you can divide both sides by 3, right? So both sides divided by 3 will give us x equals to 4. So the x-intercept will be 0, 4. I mean 4, 0. So let's plot it. There's the point 4, 0. Now to find the y-intercept, we let x equals 0 and solve for y. So we're going to cover the x and its coefficient, right? So it's covered. And then in your heads, you can divide both sides by negative 4, so y equals to negative 3. So the y-intercept will be 0, negative 3. Now we plot that point, which will be down here. Now we connect the 2 points. There's my line. Okay. Okay, now finding the slope of a line through 2 points. The slope is equal to change of y over change of x, which means it's going to be y2 minus y1 over x2 minus x1. Okay, let's do number 9. Okay, so let's do this one here. So since the first point is 9, 0, I'm going to call it x1 and y1. And since the second point, 12, 12, is 0.2, I'm going to call it x2 and y2. So if you notice, I put here on the left side, x1 is equal to 9, y1 is equal to 0, x2 is equal to 12, and y2 is equal to 12. So let's put our formula. So it's going to be y2 is 12 minus y1 is 0. So it'll be 12 minus 0 on the numerator. On the denominator, we got x2 minus x1. So 12 minus 9. So it's going to give us 12 over 3, which will give us 4. That's my slope. Now there's the number 10. Right, same manner. So x1 is going to give us negative 5. Y1 will give us negative 2. And x2 will give us negative 4. And y2 will give us 11. You see, I put them here on the left, so it's easier to see. So y2 is going to give us 11 minus negative 2 over negative 4 minus negative 5. This turns to 11 plus 2 over negative 4 plus 5 is going to give us 13 over 1, which will give us 13. My slope is 13. Let's do 2 more examples. Find the slope of the given line. The line through 5, 3 and negative 7, 3. So again, we repeat the process. So my x1 is 5, my y1 is 3, my x2 is negative 7, and my y2 is 3. Let's put them into the formula. Okay, so we got 3, y2 minus y1 is 3 minus 3, and x2 minus x1 will give us negative 7 minus 5. So this results in 0, negative 12. So the result will give us 0. Okay, now observation. I always tell my students that before they work out before they actually try to find the slope, I let them know if the y values repeat, right? For example, in this case, the y values repeat, it's going to be, the slope will be 0, right? Because if the y's repeat, we're going to give us 0 on the numerator. And then if the x values repeat, like in number 12, right? The x values repeat, the x values is going to be undefined, because if the x values repeat, it's going to give us 0 on the denominator. Okay, but let's pretend that we didn't know that. Okay, so let's work it out, and then I'll explain again the observation. Right, so x1 is 1, y1 is 2, x2 is 1, and y2 is negative 6. There's my formula, so let's plug in the values, right? So we got negative 6 minus 2 over 1 minus 1. You see, guys, if the x's repeat, right, for example here, then it's going to give us 0 on the denominator, which will be undefined. And remember, when it's undefined, it's going to give us, the equation will be x, well, that's my slope. In the next slide, I'm going to show you how to find the equation when the two x's or y's repeat. So my slope is undefined, and here's the observation. When the x values of the 2 points repeat, it's undefined slope. Okay, now, number 13. Number 13, we're finding the equation of a line. So for number 13, we actually have to find the slope, and then we have to use the point slope formula. Let me show you what I mean by that. Solution, first find the slope, then use a point slope formula to find the equation. So before, right, this is the slope formula, and this is a point slope formula. So before, let's see if we can actually, if it's going to be 0 or undefined slope. If we notice, the x's do not repeat, and the y's do not repeat either. So in this case, we have to do the work. There's my x1, which is -5. My y1 is -2. My x2 is -4. And my y2 is 11. So let's plug him in. So it's going to give us, let's see, 11 minus -2 over -4 minus -5 will give us 13 over 1. My slope is 13. Now, I'm going to use the point slope formula, which is y minus y1 equals to m x minus x1. For the y1 and x1, you can use either point. But let's keep it uniform. Let's use a y1 and the x1 value, which was point number 1. But if you use the -411, it's going to give you the same thing. Okay, so my y1 is -2, and my slope is 13, and my x1 is -5. So let's plug them in. So y1 is -2, my m is 13, my slope, and my x1 is -5. Now we have to simplify, right? So 2 negatives will give you a positive, so we have y plus 2. Same thing here with the x's in the parentheses. 2 negative will give you a positive, so it turns to x plus 5. Now we're going to distribute 13 times x and 13 times 5. So y plus 2 equals to 13x plus 65. Now we subtract 2 to both sides. So we have y equals to 13x plus 63. Okay, now, this is number 14. On number 14, right, they want us to find, right, the line of the graphs in slope-intercept form. So they want us to write the equation of the line with just a line given. They don't give us no points, right? So this is how it's done. Right, so we want the equation in that form, y equals to mx plus b, which is a slope-intercept form. So I need to find my m, I need to find my b. Because remember, the b is going to be my y-intercept, and the slope will be rise over run. So in this case, right, my b will be will be 1, right? Because that's where the line crosses the y-intercept. So b is equal to 1. Now you have to choose another point, but you have to choose another point that goes exactly through a corner. For example, we cannot use that one there. We have to use this one over here, right there, right? Or we can even use here this one in the bottom. So it doesn't matter, right? But I know this is going to be positive slope because going from left to right, we're going up. So it's going to be the rise over the run. So that's my rise, and that's my run. So how many do we go up? 1, 2, 3. How many do we go to the right? 1, 2, 3, 4. So it's 4, right? So my slope is 3 over 4. So now I got my b, I got my m, so I got my equation, right? My slope is 3/4, and my b is 1, which is a y-intercept. So this is the equation with a given graph. Now let's do the second one here on number 14. So here, guys, my b will be -2. Right? Now we have to pick another point that goes exactly through a corner on the grid. I believe this one here will be the correct one. Right? If we notice, guys, this is going to be negative slope because it's going down from left to right. So the rise, right? So this is going to go down, right? So it's going to go down all the way. Let's see, it's going to go down 1, 2, 3, 4, 5. And 1, 2, 3, 4. So it's going to go down 5. So it's going to be -5 and 4 to the right. So my slope is -5/4. And my b is -2. So I already have the m and the b. So I can plug them into the slope-intercept form to get my line. There's my m, which is -5/4, and there's my b. negative 2. So this is the equation of the line for this given graph. Now, on the third graph here, remember guys, recall, my b is negative 3, right? Remember, if you have a horizontal line, the slope is 0. So it's going to be y equals to negative 3. Okay. And on the last one here on number 14, right, we have a vertical line. Remember, the vertical line, the slope is undefined. So it's going to be x equals to whatever for the line is x equals to 4. That'll be my line, x equals to 4. Let's continue with number 15. Now, for 15, it says finding the equation of a line that goes through the point 3, 4 and is parallel to the equation 4x minus 2y equals 5. So solution. First, we need to find the slope of the line by rewriting in slope-intercept form. Remember, guys, that the slope is my m. So I have to rewrite this equation in proper form. And then I'm going to use, after I find my slope, I'm going to use the Poinsot formula. If you guys can recall from the lessons, parallel lines have the same slope. Okay, so whatever m we get here, that'll be the slope that we use. So we have to isolate the y. So first, we're going to subtract 4x to both sides. So if we do that, the result will be negative 2y equals to negative 4x plus 5. We divide everything by negative 2 on both sides. So we get y equals to 2x minus 5 over 2, right? That's a result by dividing both sides by negative 2. So now I know what the slope is, right? My slope is 2. We don't care about the y-intercept, guys. We only care about the slope because we're trying to find a line, right, that's parallel to this line, but it passes through the point 3, 4. So now we have m, which is 2, and the point 3, 4. So my x1 and y1 is 3, 4. Right? 3, 4 is my x1 and y1, and my slope is 2. All we do is plug it into the formula. So my y1 is 4, my m is 2, and my x1 is 3. Now we get to distribute. So this becomes y minus 4 equals to 2x minus 6. Now we add 4 to both sides. And we get y equals to 2x minus 2. This is the equation that we're looking for. So this line is parallel to the 4x minus 2y equals 5. These two are parallel lines. Okay, now we can solve. We can find the line in slope-intercept form another way. Okay. I will show my students like different ways to find what they're looking for, right? And then they get to decide what method is easier for them. In my opinion, this other method is easier. Okay, but like I said, this is my opinion. We all think different. So if this is easier for you guys, for the students, well, then you use this form. But if not, you can use it with a formula. Okay, now here it is, right? So we know that y equals to mx plus b. We already have my m. So I need to find my b. How do we find b, right? So we subtract mx to both sides. So b equals to y minus mx to find b. Right, so we know that x1 is equal to 3. I'm going to use the first point. I'm going to use a point that was given, 3, 4. So that's x1 and y1, and my m is 2. All we do is plug them in. Y is 4, m is 2, and x is 3. So it'll be 4 minus 6, so the answer will just give us negative 2. You see, I got my m, my slope, and I got my b is negative 2. See, it's the same result as using the Poinsot formula. Okay. Now when you have two ways to actually to find the line parallel, parallel to this line for x minus 2y equals 5, passing through the point 3, 4. Okay, now let's find an equation of the line with the given conditions, right? So now this is passing through 6, 8, and it's perpendicular to the line negative 2x plus y equals negative 3. So we're going to do the same process as number 15, But the only difference is that it's a different equation, right? But also a different point. But we're gonna find the slope by rewriting this equation into y equals to mx plus b, which is a slope-intercept form. Okay, now, so we're gonna add 2x to both sides. So we get y equals to 2x minus 3. Now recall, right, my slope is 2. If we were looking for the line parallel to this one here, to the negative 2x plus y equals negative 3, we use the same slope. But we're looking for perpendicular, so it's going to be the opposite reciprocal. Okay? So the opposite reciprocal of a positive 2 is negative, right? And then the reciprocal of 2 will be 1/2. So this is a slope that we're going to use. So that's my slope, negative 1/2, and the point is 6/8. We got my x1, y1, and we got my slope. Plug them into the formula. There's my y1 is 8, my m is negative 1/2, which is my slope, and my x1 is 6. We're going to distribute. So negative 1/2 times x will give us negative 1/2 x, and negative 1/2 times negative 6 will give us a positive 3. We're going to add 8 to both sides. So y equals to negative 1/2 x plus 11. This is the line that we're looking for in slope-intercept form. Okay, number 17. Number 17 is evaluating functions. Okay, for A, they want you to evaluate f of negative 2. For B, f of 5. For C, f of x plus h. And for D, f of x plus h minus f of x over h. And h cannot equal to 0 because if h is 0, it will be undefined. So let's start with A. Right, we're finding f of negative 2, which means I'm going to plug in negative 2 for every x. So f of negative 2, right, I'm going to plug in the negative 2 there where the x is, and also there where the x is. So we're going to plug in negative 2 there, and also there. Now we get to simplify. Negative 2 squared will give us 4. Negative minus 2 will give us positive 2 plus 4, so the result will be 10. So f of negative 2 is equal to 10. Now let's find B. I believe it's supposed to be a 5 here, guys. We're finding f of a 5, not 3, okay? So I did a mistake there. So let's find f of 5. We're going to plug in 5 where the x's are. So it's going to be 5 squared minus 5 plus 3. So we got 25 minus 5 plus 4 is going to give us 24. So f of 5 is 24. And I repeat, I did a mistake here. Instead of a 5, I put a 3. Okay, my bad. Now for C. Here's where students begin to get confused. That's why I like to tell my students, right, if we're looking for f of negative 2, right, we're going to plug in negative 2 for every x. If we're looking for f of 5, we're going to plug in 5 for every x. In this case, right, we're looking for f of x plus h, so we're going to plug in x plus h for every x. Right, we're going to plug it in there for the x and also for the both x's. So it's going to be x plus h, everything squared, minus x plus h. Now, x plus h squared is equal, right? So here we're going to do the FOIL. X plus h squared is equal to x plus h times x plus h. So we're going to multiply x times x will give us x squared. X times h will give us xh. Now, h times x will give us xh, and h times h will give us h squared. So the two middle terms can be combined because they're considered like terms. So it's going to give us x squared plus 2xh plus h squared. So we're going to replace that x plus h squared. Here's the result, right? Now minus x plus h, which means we're going to multiply negative 1 times x and negative 1 times h. Right, so negative 1 times x will give us negative x, negative 1 times h will give us negative h, and the 4 will just bring it down. So this is my result. X squared plus 2xh plus h squared minus x minus h plus 4. And if you notice, none of those terms are considered, let me go back, are considered like terms, right? So that's a result right there. Now let's find D. Because remember, guys, I tell my students that this is called the difference quotient. I like to say we're going to do it in three parts. So the first part we have to find f of x plus h. The second part we do f of x plus h minus f of x, and the third part, okay, we're going to cancel the h's. Okay. So wasn't the result from last time right? If we plug it in, right, then we get that, right? Same thing as the previous one. Right, so I'm just copying what I did on the previous one, and it was x squared plus 2xh plus h squared minus x minus h plus 4. This is my f of x plus h. Now, step 2, right? Like I said earlier, I'm going to operate on the numerator. So this is my f of x plus h minus f of x is the original function, which is x squared minus x plus 4. Now, right, so I'm going to take away the parentheses, but minus f of x, right? This means that I'm going to distribute the negative. So negative times a positive x squared will give me a negative x squared. Negative times a negative will give me a positive x, and negative times a positive 4 will give me a negative 4. Now, here's a hint that I tell my students. If the term doesn't have an h, it has to, it has to be eliminated. Okay? So for example, x squared, the first term, does it have an h? No, right, it doesn't. So somewhere there's going to be a negative x squared. You see, and there it is, right over here on the right. So we can cancel those two. Does the second term have an h? Yes, it does, right? So it stays. And does the third term also the h squared has an h, so it stays. The negative x doesn't have an h, so somewhere there's going to be a positive x. So here it is on the second to the last term. They cancel. This term has an h, so it stays. The 4 doesn't have an h, so it's got to cancel. That's why I tell my students that if the term doesn't have an h, it has to be eliminated. If not, we did something wrong there, right? We did some of the algebra wrong. So every term that's left must have an h. See, there they are. Now, I'm going to factor out an h. Why do I do that? So the h on the denominator on the formula can cancel. Now comes step 3, right? So we got h over 2x plus h minus 1. You see, the two h's will cancel, and that becomes 1. So my result is 2x plus h minus 1. I like to give this problem on the exams for 1324 because students need to know this if they're taking 1325. Okay? And this is as hard as it gets if you have something like x squared. For example, on the next one, number 18, right, we're doing the same thing. But this will be much easier because the x is not squared. It's to the first power. So we're going to do the same thing, but this will be a little bit easier. Okay, that's step 1. Again, so we're going to find f of x plus h. We're going to plug in x plus h for every x. In this case, it's only 1x. So we're going to plug it in here, right? Now we get to distribute. So 2 times x will give us 2x. 2 times h will give us 2h, and we bring down the minus 3. Now step 2. That's my f of x minus my f of x, right, is the original function. Now here, guys, with a negative here, I have to distribute the negative. So negative times 2x will give us negative 2x. Negative times negative 3 will give us a positive 3. And I repeat, the terms that don't have an h must cancel. Right? No h, so it's got to cancel with the one over here on the right. This one stays because it has an h, and the negative 3 will cancel with a positive 3. The result will give us 2h. Now comes right step 3, which is the last part. So now the h over h will give us 1, and 1 times 2 will give us 2. That's my result. Okay. Now number 19. Okay, number 19, we're going back to lines. Okay, linear equations. But here's where students begin to have a little bit of trouble because as my experience as an instructor, and also when I was a student, I used to dislike word problems because people begin to freak out when they see a word problem. And I know students feel like that too. Some students feel like that. But anyway, guys, it's not that complicated. Why? Because we're going to apply what we know. Okay, so in this case, It says a manufacturer's suggested retail price, which is called the MSRP for a base model 2016 Toyota Prius, is $25,035. And it is expected to be worth $14,115 in 4 years. So here, guys, we have three questions that they're asking. For A, find a linear depreciation function for this car. B, estimate the value of the car in 5 years from now. And C, at what rate is the car depreciating? Okay, solution. So for A part, we need to find 2 points. Okay, now, this car was brand new, right? So when it was bought in 2016, maybe I should update the 2016 and just put that is a brand new car, 2023. That way I can keep it current with the years. But when the car is brand new, right, X equals 0. So the original price was $25,035, and that's my Y. So my first point will be 0, 25,035. That's my first point. Now I need to find another point. The other point, we're going to get it from the negative 14,115, and also with where it says 4 years from now. Okay, now if the car was brand new, right, and it was 0, so then 4 years later, X is equals to 4 and Y equals to 14,115. Here is the result of the second point. Okay. Now we did what we did in previous problems where we had to find the slope. So I need to find the slope and the y-intercept. Right, so this is x1, y1, x2, y2. So it's going to be y2 minus y1. So 14,115 minus 35 over x2 minus x1, which would be 4 minus 0. This will give us negative 10,920 over 4. We divide both sides by, we divide the negative 10,920 by 4 is going to give us negative 2730. So negative 2,730. So the car, guys, is going down by this amount every year. Okay. So we got my M. Now I need to find my B. All right. So I'm going to use the formula B equals to Y minus MX. So I'm going to use the first one because it's easier because it has a 0. So my Y is 25,035. My X is going to be 0, and my M, my slope, is negative 2730. So after I execute or after I simplify, it's going to give us B equals to 25,035. So there's my equation, right? There's my M, and there's my B. Plug them in. There's my equation for part A. Okay. So here's my linear depreciation function for this car. Now for B part, it says estimate the value of the car in 5 years from now. So in 5 years from now, right? So we're going to be evaluating the function at 5. So we're going to be need to find f of 5, which means I'm going to go back to the function and plug in 5 for every x, which is only the x here with a coefficient of negative 2730. So this we'll just put in the calculator, guys. So we're going to get 11,385. So the car will be worth $385 in 5 years. Now, C, at what rate is the car depreciating? So in other words, what is the slope? But here, guys, you cannot put negative, even though the car is, it's negative, right? If you put negative on my math lab, it's going to come in wrong. Why? Because here it already says that it's depreciating. This means that it's already negative. Okay, so I tell my students to be careful on the way to input the answer on my math lab. So this means the car is already negative. The slope is negative, so the answer will be the car is depreciating at $2,730 per year. This is how you find part C. Okay. Okay, now number 20. Number 20 is a company manufactures 65-inch smart TVs that sells to retailers for $500. The cost of making X of these TVs is is the cost function is C of x equals to 300x plus 213,000. I forgot another zero here, guys. Okay, there's supposed to be another zero there. Okay. Now, for the first part, it says find the revenue function. So the revenue, guys, is how much the TV sells for. So the answer will be 500, right? But to represent a function, you have to put an x, right? So it's going to be R of x equals to 500x. This is the answer for A part. Now for B part, find the profit function. The profit function is equal to P of x equals to R of x minus C of x. So we already know what R of x is, and C of x was given, which was 300x plus 213,000. Okay. So, right, so here we're going to distribute the negative. So it's going to give us 500x minus 300x minus 213,000. We combine like terms. So 500x minus 300x will give us 200x. So this is a result of the profit function, which is 200x minus 213,000. That's the answer for B. Now for C, right? For C, it says, what's the profit of selling 2,500 TVs? So that means that we got to find, evaluate the function at f of P of 2,500. So again, we're going to plug in 2,500 where the x is. Now we plug in the calculator, so it's going to give us 2,087. So 287,000. So the result is the profit of selling 2,500 TVs is $287,000. That's the answer for part C. Number 21. Number 21, they're saying to find the vertex, axis of symmetry, y-intercepts, and x-intercepts of the function. Because, like I tell my students, when the equation is in this form, ax plus by plus c, right? You have to know that there are certain things that are visual. So without doing the work, we should know certain things. Okay, but let me show you how to find the vertex, how to find the axis of symmetry, how to find the y-intercept, and the x-intercept. Okay, now, the y-intercept, guys, is visual. So we should know that the C is 9. Okay, so we know that the y-intercept will be 0, 9. Okay, but let's go in order and find the vertex first. This is where I try to tell my students that what's visual, what can you do? What do you know about the function with what's given? We should know certain things, right? But anyway, let's find the vertex first. For the vertex will be negative b over 2a and f of negative b over 2a. This formula seems kind of intimidating, right? But it's really not. So the first part is the x value of the vertex. The f of negative b over 2a means that once we find the value for the x here, the negative b over 2a, we plug it back to the original. Okay, let me show you what they're talking about. So I need to know the values for a and for b. The a is equal to 1, right? Because there's no coefficient there, so we know it's 1. And the b is 10. So we're going to plug him into the formula. Right? So we have negative 10 over 2 times 1 because b is 10 and a is 1. I repeat, the formula says negative, right? So don't get confused with a negative. So it's negative 10 over 2 times 1 will give us negative 10 over 2, which will give us negative 5. So that's my slope. Not my slope. That's my x on the vertex. Now for the b part, for the y part, I need to find f of negative 5, which means I'm going to plug in negative 5 back in the original. Okay, which will be negative 5 squared plus 10 times negative 5 plus 9. This will give us 25. 25 minus 50 plus 9 will give us negative 16. Okay, because it will be 25, right? 25 minus 50 will give us negative 25, and then when we add 9 will give us negative 16. So this is my slope. My vertex, I'm sorry, I keep saying slope. The vertex will give us negative 5, negative 16. Now, for the axis of symmetry, it's going to be x equals to negative b over 2a, right? So it's going to be x equals the x part of the vertex. So x equals to negative 5. That's my axis of symmetry. My y-intercept, right, is my c. My c is 9. So that's kind of visual, right? Without doing the work, we should know what it is. So it's going to be 0, 9. Now for the x-intercepts, we have to know how to factor. Okay, so we're going to let y equal 0, or the f of x equals 0, and we have to factor. So in factoring, right, we know because the 9 is positive, we know the signs are going to be the same. And they're both going to be positive because the bx term is positive. So we're going to get x plus 9 and x plus 1 are the factors of x squared plus 10x plus 9. If you guys struggle with factoring, you can come to Sunday numbers. I have Sunday numbers every Sunday at the TM campus, or you can go to tutoring and they can show you how to factor. So we have x plus 9 equals 0 and x plus 1 equals 0. So we subtract 9 to both sides. So we get x equals to 9 and x equals to negative 1. These are my x-intercepts. Negative 9, 0 and negative 1, 0. Now, this is in the form ax plus bx plus c, right? Now, this one is going to be in vertex form. Or there's different names, for it, depending on the author. At times, they call this vertex form or they call it standard form. But anyway, the book says, the rule. Okay, that's what this particular book states, this equation, just, the rule. Okay, so anyway, if it's in this form, there's different ways to find the vertex. The axisymmetry will be almost the same. The y-intercept and the x-intercept, we have to solve for y, and also here we have to find the x-intercept. We let y equals 0 and we solve for x. So for the vertex, guys, the vertex is visual. Okay, the vertex and the axisymmetry are visual. These two, we have to work them out. No, so we have to know what the h and the k is. Right, so this is my h, and that's my k, right, from the vertex. So then my vertex will be negative 3, negative 16. The axisymmetry is always the x part of the vertex, so it's going to be x equals to negative 3. A lot of students make the mistake is that they don't put x. They just put negative 3, which is wrong, because the axisymmetry is actually a line. Okay. Now for the y-intercept, we have to let x equals 0 and solve for y. Like I said, the intercepts require work. So now, okay, let's let x equal 0. Right, it's going to be 0 plus 3 squared. So 0 plus 3 is going to give us 3. So then 3 squared will give us 9. 9 minus 16 will give us negative 7. So the y-intercept will be 0, negative 7. Now for the x-intercept, okay, this one, guys, if you want, you can distribute it and then try to factor. But if it's already in this form, I believe it's easier to go ahead and solve it the way it is right here, guys. Okay, let me show you how it's done. So we're going to let y equals 0. So we get 0 equals to x plus 3 squared minus 16. So we're trying to solve for x, right? So we're going to add 16 to both sides. Now, to get rid of the square, we need to take the square root of both sides. Okay, so I just put the x plus 3 squared on the left side, because most of the times we have x equals to something, right? So to keep it in the same format. So when you take the even root of a number, right? The even root, you're going to put plus or minus. So this is square root, right? And it's even, so we're going to put plus or minus. So the square cancels the square root cancels the square. So that's like 1. So it's going to be x plus 3 equals to plus or minus 4, because the square root of 16 is 4. Now we're going to subtract 3 to both sides. So we get negative 3 plus or minus 4. So it's going to be negative 3 plus 4 and negative 3 minus 4. So negative 3 plus 4 is going to give us 1, and negative 3 minus 4 will give us negative 7. So these are my intercepts. It's going to be negative 7, 0, and 1, 0 are my x-intercepts. So I'll just show you 2 examples how to find the vertex, axisymmetry, y-intercept, and x-intercepts when the equations are in different forms. Okay, now, how do you apply this in real life with a vertex, okay? So it says the revenue of McDonald's Corporation in billions of dollars for the year 2010 to 2015 can be approximated by the function R of x equals to negative 1/2 x squared plus 13x minus 57, where x equals 7 corresponds to the year 2010. So this is also three parts. For the first part, they want us to find the vertex. For the second part, this is supposed to be in what year? And what year during this period was the revenue at a maximum? What was the maximum revenue to the nearest $1 billion? Okay, so let's start. So the part A is find the vertex. So this is the formula for the vertex. Okay, so my A will be negative 1/2, which is negative 0.5, and my B is 13. So we plug them into the formula, we're going to get negative 13 over 2 times negative 0.5, which will give us negative 13 over 1, which will be, it'll be negative 13 over negative 1 will give us positive 13. So that's my X part of the vertex. Now for the Y part, we're going to evaluate R of 13, which means I'm going to plug in 13 for every X. So we put that in the calculator, so it's going to give us 27.5. So for A part, the vertex will be 13, 27.5. Now the B part will be the X part of the vertex, right? It says in what year during this period was the revenue at a maximum? If X equals 10 corresponds to 2010, so this will be X equals 13, corresponds to the year 2013. So the answer will be in 2013. Okay. Now for C part, what was the maximum revenue? Hey guys, the Y part of the vertex is always the maximum or the minimum revenue. So in this case, we got, but it says to round off to the nearest $1 billion. The Y value of the vertex is the maximum revenue. So it was 27.5, rounded off to the nearest billion will give us 28. That's the answer for C part. And I believe this is it for this workshop. And all those problems that I gave you, I believe most instructors will give, perhaps not all of them, but at least more than half of them, will be on your exam. So good luck on your exams, and come back next week for Friday Math Happy Hour.